Ladies and gentlemen, up next here in track 2, we are going to be discussing scaling across data centers using Linux high availability with Jeremy Rust, sales engineer with LINBIT. Is that correct? LINBIT. Mm-hmm. Along with Devin Vance, lead engineer, also known as the Cluster Wizard. Ladies and gentlemen, please put your hands together.
Hi there. So like you said, I'm Jeremy Rust. This is what we're going to be presenting on today, scaling across data centers using Linux, high availability, and disaster recovery. So a few of the things we're going to talk about is, of course, downtime. As you guys know, we've talked about it a lot. It costs a lot of money happening at any level. High availability, of course, is different than a backup. There can be similar, but a backup is a different process, usually coming back from time. We're going to talk about the Linux HA stack using DRBD and DRBD Proxy, as well as a cluster resource manager. What it looks like when you kind of take applications that are not clustered and turn them into a cluster. The cluster resource manager, Pacemaker, disaster recovery, and linking different sites together, different data centers for live replication between them. And of course, we have a demo showing failover between sites that is completely automated. So really excited today. Last year, we covered this pretty in depth. You see a whole bunch of different blocks coming in. DRBD, for those who don't know, is a block device. It sees everything coming in as just blocks of data, replicates them live right next to each other on 2 machines, and then it can also send it live over the internet for a third copy. So we covered this pretty in depth. I did a talk on it. You can find the YouTube link here. Andy Briss did another one talking about a number of different failover solutions. I encourage you to watch them. This one's a little bit more technical, gonna go a little bit more in depth. So the reason we did this last year is because we kind of saw the writing on the wall and a lot of people listened to your guys' feature requests, which is why this year we are extremely excited to announce between LINBIT and Nagios that we have a new tech guide, completely open source that we worked on together, detailing how to set up DRBD with Nagios XI. I have the PDFs of it. You guys will be able to find it online. The link right there is to our tech docs from LINBIT. And of course, I can just email it to you guys or however you prefer. We put a lot of work into it. It has full configs, everything you guys need to set this up locally. I do want to stress it's made to set up with 2 machines close to each other. If you're going to do it over the WAN, lots of other considerations. And as always, Andy said this best, test, 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 do it in a lab first. So you guys know that. Of course, this year we're showing you how this can be more scaled and a more flexible storage-defined infrastructure. Everything is open source here. This is DRBD 9 and kind of the conceptual overview of it. For you guys, I know that you guys always have more and more roles and more responsibilities. So having a copy of Nagios or having your monitoring system on 1 site or now 2 sites can become many, or maybe you need to look after many different data centers, many different aspects of your organization. So of course, this all comes back to your service requirements and what is kind of the focus of what you're hosting for your resources. These are all the main tenets. You guys know these very well. Scalability, uptime, how long it takes to recover, are you practicing coming back from your backups? Is there a switchover solution? Well, us and Nagios are really happy to say yes, there is. We have the tech docs. So, clustering solutions. There is a whole bunch of different ways you can do this. Hardware redundancy is a good step. There's SANs and different types of arrays. So NAS boxes, SANs, external JBODs, bunch of different ways you can have your storage. Of course, hardware redundancy is a good first step. I'm going to be mostly talking about today is software solutions. It's a thing that a lot of people are starting to consider. DRBD is one of those great options to help you reach your recovery point objectives and provide a switchover live. So what this looks like, kind of coming down things, is you have backup snapshots, you have a full timeline of where you may need to recover and where that incident may happen. If it happens right after a backup, great. Take a backup snapshot before, maybe upgrading to a new version or something. We in our tool, though, DRBD, work only in the real-time aspect. We're not a backup solution. We only do the real-time part. And with this, there's many different things to consider, both on the hardware side where it may fail. Maybe you're in an earthquake zone. Maybe you're over hosting in Amazon EC2. Amazon just had a giant outage this year on the East Coast. We also, of course, this year we had a customer who, despite having redundant fiber lines, their neighbor was doing construction and dug right through them. And while connectivity of fiber is awesome these days, it's not as easy to fix or repair as copper was. So, multiple instances, keep your data in different places. Different things to look for in software solutions. There's a whole bunch of different things. You guys probably want something very stable and mature. LINBIT and DRBD has been doing this for 14 years now, and we're in the kernel. On-site, off-site things, synchronous, asynchronous. What is your chance of data loss? I really wanted to recap one of these things, which is asynchronous. So asynchronous means data comes in, it goes to one machine, and it's pushed to the other one. There's no confirmation going on there with the I/O. What we do with DRBD is fully synchronous when you're using it locally. So it looks like this, where data comes in, it's confirmed on one machine, sent to another machine, confirmed again, then the acknowledgement goes all the way back to whatever resource is coming in. Doesn't matter if it's a file system or a database, the write isn't confirmed until it's on two completely different machines. With fast networks these days, that usually only means 1 to 3% overhead. So here's what it looks like set up with Nagios and what the tech guide walks you through. You'll have two separate machines, which we call nodes, connected underneath at the block level with DRBD replication. You'll have a communication layer using Heartbeat or Core Sync, and the cluster resource manager sits on top using Pacemaker. This is just a very big conceptual overview. Now, I want to come back to this and how it gets provisioned across a virtual infrastructure. So what you see here is 5 different resources in different colors, either replicated 2 ways or 3 ways on 5 different machines. DRBD 9 handles this extremely well. It's made for scaling. You can just attach another machine, add it to the cluster, and you're good to go. This can be done both virtually in a bunch of different VMs or with bare metal hardware. So if you have a bunch of resources, you have a bunch of machines, things can get pretty big and complicated quickly. Maybe you have all these host machines up top, with your web server, your database. You can replicate the host servers separately from the storage servers for another level of redundancy, or if these machines are really resource intensive. So this is really exciting because it means that you don't need to rely on a hypervisor or add complexity higher up the stack. You can kind of take care of all of this down below the application, and the application, like Nagios, doesn't need to be cluster aware. Now, it's really powerful for a lot of those reasons, and this is why a lot of big companies have hooked it up, have set this up. This is a few of the people using it. Many of them are clients of ours as well, and we're really excited that DRBD has such a giant community around it, even though it is a pretty small developer source coming mostly from LINBIT. The community is really big, giant mailing list, lots of IRC channels. Really excited about how some of these people put this to use. So how they're using it is usually with multiple resources. In a fully redundant system, here's how it looks. You have MySQL coming into one storage box going over to the other with another passive machine on the other side. So you have your active and your passive. Now, that usually doesn't lead to full utilization, so people have multiple resources. Some on one side, some on the other, active on one, passive on the other, active with a different resource, passive on the other. So you can see that there's a lot of things that start coming up here. And this is where, different types of configurations and considerations need to be taken into account. With DRBD and this Linux cluster stack, it will run on anything that runs Linux. Anything from Arduinos and Raspberry Pis to supercomputers and high-performance compute. It does need to be tuned, and there's so many different things happening at this layer. So keeping in mind that your different types of I/O, how much throughput you're using for maybe a file system, what type of latency you have over your network, if you're doing it in a data center or between data centers. With the flexibility to use it anywhere, both virtualized and on bare metal, of course you need to tune it. So that's why I always like to say it's a tailored install for a reason. Do what fits you best. It will work for your infrastructure. There's a lot of great pointers out there. There's a lot of great tuning guides. Tons of documentation, hundreds and hundreds of pages. Our tech guide, walking you through setting it up with XI, will touch on a bunch of those, as well as provide you the full config. So this is how you kind of tailor it to your environment. I've mostly been talking about, how this can be used locally. The big thing, though, that's growing is how you want to use this between sites. So for us, I'm based out of Portland, Oregon, and we live replicate everything to Vienna, Austria, where our headquarters and our developers are. The tool we use to do that is DRBD Proxy. It's an add-on to normal DRBD, still works with the whole cluster stack, and it allows for basically a giant send buffer as well as inline compression. So if you have a whole bunch of writes coming in and you can't push it that fast over your constrained network, compress it, buffer it, send it over when there's more throughput available. So here's kind of what it looks like and what our demo looks like today that Devin will be showing us. So we have 2 machines at one data center and 2 machines at another. One is in Portland, one is in Beaverton. They're going over the internet with DRBD Proxy. And actually, we have a 5th machine up at a 3rd data center, which is just kind of represented by the global network, which is an arbitrator. So you have 2 sites, 2 data centers, and an arbitration site that watches both. The arbitration site, it needs to be there on a separate physical system or separate place so that it can watch the internet connections between everything and provide like a true quorum. So it knows when something is up, it knows when something's down. If internet connection to your data center loses for whatever reason, maybe there's an earthquake, who knows, it will take note and say, oh, all my services, I can no longer see them from 2 different connections and data centers. I better start those elsewhere. And that's what we're going to be showing off today, is that live failover between sites. DRBD Proxy is just kind of taking care of the replication. Now, I said that you can use compression and buffering. If you're using this with a really active system, or if you need a really high amount of compression, like LZMA or LZ4, and you're using, say, a 5 terabyte file system, you're probably going to want to offload that compression to another box. So Proxy can do that. You can just have a dedicated compression node. It also stages the data to send it fast over the internet. So yeah, it can be used in any virtual system. We're going to be showing it to you on bare hardware. But of course, this can be set up in AWS as well, or your kind of virtual private cloud, or your VM instances. The reason I come back to this again is because I know many of you may not have your own box or your own data center. You might get that from other teams. Using DRBD, you can do it inside of your own project. So you don't need to go to the network team. You don't need to go to the storage team. You can set this up just for your application over the top of whatever they're providing you. So that's the really exciting point, and our guide should be able to help you do that. And of course, either come to Nagios or come to us, and we'll be happy to answer your questions. And I'll let Devin take over to show you guys the demo.
Great. So as Jeremy was saying, for years now, we've been able to replicate data via DRBD. And with the Linux HA stack, we've been able to fail over locally for years now. So what I'm going to demo is the new project Booth. It actually facilitates automatic failover to your DR site via Pacemaker and DRBD. So what in previous times had to be facilitated via a script, we can now do automatically. And I'm really excited. This is a new project just coming into maturity now. OK, so for this demo, I just have a simple web server going. So if anyone's familiar with Pacemaker, this is kind of how the output looks from the terminal. I have 2 nodes in this cluster, Lab A and Lab B. And they manage these resources here. I have a replicated file system via DRBD, a web server, and a virtual IP point as web server. And this web server here, just real simple web server, shows the output of some log and an image. And I have that constantly refreshing so I can show the failover. So I'm going to kind of breeze through this real quickly, and then just make sure we have time for Q&A. And if anybody wants to see something more specific, I'll be glad to do that. So I'm going to simulate a site failure with a simple script that's just going to throw up some IP table rules. And don't buy a refurbished laptop. .sh. I learned that one the hard way. OK, so what I'm doing here is throwing up some IP table rules here. So we have a site failure here. Right about now, you're probably going to get some alerts that the connectivity to this site's down. And it's going to take a moment. But I mean, since we're doing this across a WAN connection, we need to allow for the generous timeouts, because WAN connections are inherently kind of flaky at times. So if we give it a moment, it will. We'll see services stop, but I believe it'll take about a full minute, actually. But that's the downside. But since we're doing this across the WAN, we need to do that. A little more about this cluster. We have some VMs at my house in Beaverton, which is the southwest suburb of Portland. That's this laboratory cluster here. The one in the right terminals is in my buddy's house on the southeast side of Portland. A couple other KVM VMs running a cluster. These 2 clusters are not aware of each other. And then at our office in Portland, we have our arbitration node. It's aware of these 2 clusters, but independently, they are not aware of each other. So connectivity is down. This site doesn't know. I mean, ideally, we can't access. We don't know if it's still serving services. But the arbitrator node knows it can't reach it. And pretty soon, its ticket should expire. And we'll see services stop. And all 3 of these sites are connected via an IPsec VPN. All right, there we go. So we saw the services stop here. We actually have an outage. Services are not running anywhere. Part of the software is we need to wait for the time to acquire the new ticket. This is to make sure that services stop here successfully, or we can have time to fence the node if needed. And the idea behind that is, say we were actually doing a database, and perhaps the connectivity's down, but I'm still getting some writes locally. I need to make sure that's fully stopped before I promote it and start it on the other side, because I don't want to run into diverging data. So yeah, at this time, the site's down. And here it's up on the other site. And if I just simply refresh the page, we're up, but we're now live in Beaverton, or as the name it loads, Portland. So there we go. We had an entire site failure, and within the course of 2 minutes, it totally handled the failover. I'm now running in a completely geographically separated site with the same data set, same services up. I mean, a whole site failed, could have happened in the middle of the night. I could have kept sleeping. So that's the beauty of the Booth project. And it's called Booth because we facilitate this by handing out tickets, and whichever cluster holds the tickets able to run services. So thus the name Booth. As I said, the demo is going to be pretty brief, but that kind of shows how it works. And I guess we'll take questions if anyone has one. Thanks.
Feel free to put your hand up in the air. I'll come by personally with the microphone. Anybody has any comments or questions?
You're saying the document is for Nagios XI. Does it apply to core? Or do we have to do more figuring out?
Nagios XI has a lot more services and parts to it. So yeah, it can apply to core. Probably much easier.
Yeah, it could be easily adapted to core. I wanted to do this demo to show off the Booth, so the automated between DR sites, but we actually have a cluster that's running Nagios for local HA. Could be adapted to this as well if you'd like, but I'd be more than happy to show that privately after the show out here in the Commons area.
But as far as the documentation you mentioned, yes, it's covering all the same resources. Your config will just be shorter and easier.
Any other comments, questions?
Has anybody played with DRBD in the last year?
So quickly, I was just going to ask, so if, let's say that the data center is down, what about if there are problems with the services and we deem that the box is unoperational for whatever other reason, not necessarily the servers are down or maybe there's some corrupt configuration or stuff, can we still initiate somehow remotely that it goes to a different data center?
Yeah, absolutely. So with this one, I just did the network failure. I didn't want to kill the nodes because they're not here, and I didn't want to have to call someone to reboot them. But so Pacemaker's monitoring these services. Where's my cursor? So here we go. We're monitoring right now. I'm monitoring the file system, which has all my website's data, my website, and a virtual IP, so that if it fails over, I can find it wherever it goes. And I'm actually running a monitor on these, I believe, every 30 seconds. And if there was any issue with this service, we'd try to restart it locally. If we couldn't do that, we would fail it over. So, I mean, we're monitoring the services. Should the whole entire node die for whatever reason, I mean, the cluster communication layer is going to pick up on, hey, this guy's gone. We need to start these services somewhere else. And that's fully automated.
But you can also do that manually. You can issue the commands manually to move services primary where you want.
Yeah, absolutely. I could revoke a ticket, issue it somewhere else, and it'll move wherever I assign the ticket.
And that's how many commands?
2, revoke and grant.
Great. Any other questions for
In failing back when the original site comes back, how do you take care of that, and then also the replication thing?
Okay, so the replication is handled by DRBD. Hope I typed that properly. Okay. So I'm replicating 4 ways. This current node's the secondary, this one here is the primary, and that's all 4 ways. So that all kind of happens in the background. As long as DRBD is working, that's taken care of. Naturally, you'd want to monitor this to make sure the replication doesn't break. Failing back's fairly simple. That would just be a Booth command. I would just revoke the ticket from this side, grant it to this side, and in the course of a few minutes, it'll fail back. And as long as my DRBD is reporting that all of my sites are up to date, they all have the same current data. So it'll be 2 commands, revoke and grant.
And so I think he's wondering if you fail over to one site, I/O keeps happening, you're continuing to monitor, and then the second site comes back. So it will resync the data, only the changed data, back to the other site. And then as soon as it says up to date in the status, you can migrate back. And you'd probably want to do that manually. Most people don't want to change what data center they're running from, automatically in that case.
Yeah, I was just wondering on how to do that because in my previous role, I was with a storage company, and we do it like do our replication in the storage level, and obviously in going back we have to make sure the copy replica will be all okay, and we do it manually also. But
Okay.
of course it's nice to have it automatically, but then you have to make sure if the other site is fully good and ready. Or I mean the original site, in your case, the Beaverton.
Right, and DRBD is reporting that all sites are now up to date, so the data should be consistent. We have features where we'll actually do a checksum on each and every block to verify that everything is current, and you're more than welcome to run that before you fail back. Or if you'd like, you can actually break replication, go primary, browse the file system all you want, make sure it's all there, reconnect them, and then fail over. And like he said, if replication breaks and we need to resync, we keep a bitmap, and we log all areas of the disk that have been written to since the disconnect, so we'll only sync that. We don't need to do a full block device sync in events where replication does break via a network issue or interface goes bad or something of that nature. Any other questions?
Since we have a few minutes left, can you show a quick demo if else you have a setup of Nagios? Instead of showing that the page that you are shown, can you show a quick demo on disabling a service in Nagios, shut down that instance 1, and let the instance 2 pick it up, and show the same status of Nagios on a dashboard?
I would be more than happy to do that after the show if you'd like to see it.
Okay.
I actually don't know where those demo systems are at the moment,
Okay.
so I'll have to ping a coworker, get those IPs, connect to those. And
Because in my scenario, I have a great difficulty of getting this retention data file. We do backup now, and if something, it's all through Chef. So if something goes bad, we spin up a new node in 2 minutes. We create the configuration using Chef in 3 minutes based on the node type. And then we try to recover the retention file that we had the last backup. But in not all the cases, the Nagios will be happy in taking the retention file of previous instance and running it normally. When I say normally, preserving all the retention data about downtimes, acknowledgements, disabling, enabling. What happens is sometimes, most of the time, the surprise is that Nagios will try to recheck everything from the beginning because the retention file doesn't go well. The backed up retention file doesn't go well, so it has to recheck everything from the beginning. And we lost all the instant numbers, tickets we created for those issues, the disabling notifications, enabling notifications, everything is gone. So that's the biggest problem we have today, and I'd like to see a demo with the high availability setup that you are trying to address using Pacemaker and all the solutions, DRB and all
yeah,
that.
absolutely. Let me check out of the hotel, and I'd be more than happy to show that to you.
Thank you. Okay. You're here?
What's that? Yeah, I'll meet you out in the commons area, and I'm more than happy to show you.
And I think kind of just to follow up on that, recovering from backups, you lose a lot there, and the current status, right? The current status of Nagios. Because it's live replicated and the entire service is, the whole database is, if you're using XI and all those things, it just picks up exactly where it left off. It just needs to be brought up on another system. So one system crashes, the other one has all the exact same data. And that's because we are doing that synchronous write cycle. Because that synchronous write cycle is happening underneath, you don't lose a single transaction. Oh.
But we use Nagios core, so we don't use NDO ETLs, we don't use database piece because we don't need it. Our use case is more of live status, and we build everything on top of live status. We don't depend on database at all. The biggest challenge is the only source of truth for us, the last status, is retention file. And we sync the retention file from the status.dat file gets synced to retention file every 60 seconds, right? And say node 1 crashed for some reason. Nagios crashed on node 1, or the arbitrary node says, I can't reach the node 1 because there's a problem with node 1. It has to spin up the node 2 instance up. I mean, it has to bring the services up on node 2, but at the same time, the node 2 has to be aware of the last retention data that node 1 is aware of. Let's say we are backing up every 15 minutes retention file, and then now the node 1 crashed at 11:10. So 11:15 is the next backup, but I have a backup at 11 o'clock. So node 2 knows there is a backup at 11 o'clock. Now, when you spin up Nagios every time, it knows the previous state of it by retention data, right? Now the backup file exists, but not in all the cases that I was successful having the retention data still exists, but I can't use it because Nagios is not happy with it.
Right.
I just trying to find a right solution for HA, in Linux HA.
Yeah, so DRBD is going to replicate that whole file system. So anytime you write to that file, it's going to make it to the peer. We won't even acknowledge that write is complete until we know that write's made it to the peer. So that file should be always up to date across all nodes.
Yeah. I like to see demo on this.
Certainly.
Just interested more on this to deep dive. I couldn't find the right solution so far.
Yep.
Thanks.
Excellent questions. And if anyone cares to be interested in that, I'm sure after they check out, they'll be able to assist you with any further questions. All right, excellent. Anyone else with any final comments or questions?
So is the solution from your application perspective that we're talking about, so if you gave an example of multiple data centers and other places where we're doing the replication. So do you have documentation to actually provide high availability within the data center and then out of the data center as well on that PDF? Excellent. That's what just I want to know.
The PDF that we're releasing today just focuses on in one data center. We'll likely expand that to include, going both in one data center and to another one. That just uses our add-on module, DRBD Proxy, if you have a long distance. But yeah, it's documented elsewhere in all of our documentation. So it's not exclusively in that tech guide, but it's certainly something that we can work on for you.
Excellent. Thank you.
And so if there's any questions you think of after the show, I mean, you can reach us, via Jeremy's email. We have an IRC channel, mailing list available, all found at these sites.
Thank you very much.
I got one more here for you.
Oh, okay.
Actually, guys, the question isn't for you. It's actually for the audience. And I was wondering could I just see raise your hand if you're interested in pursuing this option with DRBD for high availability? How many people in the room? Awesome. Cool. Thank you, guys.
All right. Well, ladies and gentlemen, once again, Jeremy Rust and Devin Vance, please put your hands together. Give them a big warm round of applause.